Okay, this week we're going to be talking about minerals. You need to bring your notes to class on Wednesday when we have the in-house field trip. Okay, first thing you need to know, so sorry about that, is the chemistry behind minerals. This is going back to 6th grade for you all, and just kind of a refresher. I'm not going to test you on it, but just kind of keep it in mind. Matter is anything that takes up space and has mass. An element is the simplest substance. It cannot be broken down any further. And an atom is the smallest part of an element that shares its properties. And remember, atoms are made up of protons with a positive charge, neutrons, which are neutral, and electrons, which have a negative charge. You can write down anything you don't remember. I'm not going to test you on it, though. We're skipping the videos for now, okay? Okay, a mineral, which you need to know this definition by heart, so copy this down, please. A mineral is a naturally occurring inorganic solid with a definite chemical composition and a crystalline structure. When you have your tests on this, probably next week, next Tuesday or Wednesday, next Wednesday, the 21st, when we have a test on this, you are going to have to write the whole definition down without any matching or multiple choice. Okay. Make sure you know that inorganic means from things that are not living, and a crystal has a definite repeating pattern. These are examples of crystals down here in this picture down on the left. I'm not going to test you on them, just make sure that you know a crystal has a definite repeating pattern. Minerals come from magma primarily. Most are made up of the 8 most abundant elements in the Earth's crust, which you also need to memorize. So you can either copy the pie chart down here, or you can just write out the names of these abundant elements. Oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. Okay, some mnemonics to help you remember them are listed here. If you don't like these mnemonics, don't use them. If you want to make your own, go forth. Make sure you know what those 8 elements are, though, because you definitely need to know those. Okay, physical properties of minerals should be your title. The number 1 under the title is color. Color, when you look at a mineral, you'll clearly see the color on it. Make sure you know that color is not necessarily a reliable indicator. In the example I have here, azurite is always blue, but the shades of blue can differ. Color can change due to slight composition changes or even from chemical weathering. Number 2 for physical properties is luster. Luster is the way that a mineral reflects light from its surface, or it says the way it shines, but the way it reflects that light is what I'm really looking for. Examples of luster are metallic. So if it looks like metal, it's metallic. If it reflects light like a window would, like glass on a window would, then it's glassy. Pearly, silky, those are pretty close to each other. We'll see examples in class. And dull means that it doesn't reflect light in any way. Number 3 is hardness, and this is the ability to resist being scratched. When we check for hardness, we use something called the Mohs hardness scale. It's here on the right-hand side, sort of. We're going to do lots of activities using this. You have to be able to use the hardness scale, but you also need to know that talc, right up here, is number 1. It's the softest, and diamond is number 10, which is the hardest. Okay, number 4 for physical property is streak. Streak is the color that a mineral writes on a streak plate. A streak plate is like a rough surface, like an unglazed tile. The 5th physical property is density. It's the amount of matter in a given object or a given space, and density never changes. The 6th thing is crystal shape, and it's the way the atoms come together. There are 6 crystal shapes. Number 7 is cleavage. This is the way a mineral splits along a smooth, definite surface. When you break a mineral, if it always breaks in these flat planes every single time, that's what cleavage is. And fracture is number 8. This is when your mineral splits along a rough, jagged surface. It's sort of lumpy, bumpy. It doesn't have like any flat areas to it. Some special properties that you need to know are down here. Okay, you need to know these also. Magnetite is magnetic. Fluorite, which I'll show you in class, glows in ultraviolet light. Halite, if I let you taste it, which I'm not going to. but if I let you taste halite, it literally tastes like salt. Sulfur is bright yellow and it smells like rotten eggs. If we put acid on calcite, it'll fizz. And the one that you will not be seeing is uraninite, and that is radioactive. Okay. This is an example of cleavage here. You'll see whatever kind of element this or mineral this is. Every time it breaks, it'll break in these flat areas. This over here is fracture. You can see they're kind of lumpy, bumpy. Whenever they break, they don't have a definite flat area to them at all. These you don't really need to write down because I'm hoping you know them. Metals are shiny, they conduct heat and electricity. Non-metals are dull, and they do not conduct heat or electricity. Okay, some minerals that you need to, okay, wait, let me restart that. Minerals are used for specific things. So minerals are used to make things from simple things, like dyes and salts, or complex things like dishes and TV sets. In order to get the usable part of a mineral, you need to do something called get the ore out. And that's when you take the metals or the non-metals from the actual mineral. Basically, it's in the process called smelting, where you melt it down, and once it's melted down, you can separate it. Once smelting came about, that led to the Iron Age, if you're a history buff. Okay, valuable minerals are called gemstones. These are minerals that are used for jewelry. And that's the only one you really need on this page right there. You need to realize that gemstones are minerals, so they're naturally occurring in organic solids with a definite chemical composition and crystalline structure. Amber and pearl are not minerals. Amber and pearls basically come from living things. So amber is fossilized tree sap, and pearls, basically it's the mucus that an oyster or a shell puts around a particle of sand. And then we have some semi-precious stones, which you don't need to know. So basically, no, gemstones are minerals that are used for jewelry. Amber and pearls are not minerals, but they are used for jewelry. In case you were wondering what your gemstone for your month is, or your birthstone, there they are. Aren't they pretty? Okay, I am collecting these 7 questions on Tuesday. So, I'm sorry, on Wednesday. I got the wrong day. On Wednesday, I am collecting these 8 questions. Let me fix that really quick. There we go. So make sure you get these done. I'm not going to look at your notes, but I am going to look at these questions right here. Have a nice night.